different areas of the brain and how the brain in humans and rather in all animals developed. So we started with the development of the reptilian brain, or this is known as a triune theory of the brain. And it's a pretty popular concept where you will see that people talk about the initial development of the brain was in the lower areas. So why? So this helps us to survive. So it would help us to respond to stimuli immediately, react and repeat a task and so on. And then develop the emotional area of the brain. So this is the way the brain started developing. I don't know if you can see the cursor. Sorry. Can you see the cursor? Yes, no?
Yes, ma'am, it's visible.
Okay, great. So then this area started growing, and finally the cortex, so the upper layer of the brain. And we have so many folds because it helps to store more number of, or give space to more number of neurons. So as I mentioned earlier, that our brain, the human brain, is the optimal functioning brain, or I should say it has the optimal size as per the body's weight, and it has the maximum closely concentration of neurons in the cortical area. So this is the cortical area, and this developed last, okay, in the human species. Why? Because the more we thought or the more we think, the better the associations are, and gradually over centuries, over ages, this area developed. Now, if anybody asks me that, well, if we are thinking now, so maybe in another 1,000 years or 10,000 years, will this grow larger beyond this? Because we are thinking more and more with every passing day. So because we are actively using this cortical area, will this grow larger? We, honestly speaking, I don't know. In fact, scientists don't know. But to think of it technically, as of this point, our body's structure is optimal. So a larger brain, if we have a larger brain, then our body will not be able to, our neck will not be able to hold it. Okay, if we, and obviously the shape of our face will also change, but we don't really know. So our focus in this course, and especially in my place, my area, will be on the limbic brain, okay, and its role in the neocortex. But the funny thing is that these can be measured with some response features. Okay, so what are these response features? So it could be outcome measures that are actually that can be measured in body, from the body parameters like heart rate, then EEG. So that's another tool, that's another instrument that you place on the cortex to understand the electrical impulses. Then there are some other mechanisms like skin temperature, then respiration rate. So all these change when when we are thinking. So not all the parameters for thinking or for the limbic system, but if an individual is emotional, say happy, there are some changes in the bodily parameters. Similarly, there's an echo, so please switch off. Okay, so fine. So now we know that from the brain. Now this is a turned brain. So here it was facing, the face was facing on the right. Now here in this, the face is facing on the left. Okay, now you see the frontal lobes. Now the brain can be divided into 4 lobes. So I already told you about it, but I'll just repeat it for a few minutes. So the frontal lobe is the frontal part, which is the thinking part. So now when I say the four lobes, it's divided into four lobes, it's actually the upper part. So this crust is divided into four lobes, not these structures. Okay. So this crust is divided into four lobes. So the frontal lobe is primarily, coordinates the thinking, the motor functions, the planning, the decision-making tasks. The parietal lobe is more related to movement and coordination. So if I need to understand, so if I'm just going out of the door, okay, out of a room, how much space do I need to keep between the wall and me so that I don't bang on the wall? Now, do we actually think when we do this, when you're walking out of the room, do you have to plan, okay, I need to leave 6 inches so that I don't bang on the wall? Or, if you're carrying a bag, a handbag or side bag, do you actually calculate that, well, this is the width of the bag, so I need to move further in so that I don't hit the wall or hit the edge of the door? Now, these things, how much to move, how much to how to where to look if there is any information. See, there's a sound, there's a loud sound. So where is that sound coming from? We don't look randomly. We look at that particular sound area. If somebody is calling your name, okay, in a crowd, you don't look randomly. You look at that area, direction where from where the person is calling you. So how do we understand that? So the parietal lobe primarily is the area which coordinates this. The occipital lobe is its main focus. It has a couple of other functions also, but its main function is vision. Okay. And the primary information from the eye goes to this occipital lobe. And this area of the brain, along with the frontal lobe, coordinates, what is to understand what is this thing that we are looking at. Right now, you're looking at an image. If you look at this image of the brain, you may be looking at, so the colors are, it's a 2D image with multiple colors. But because I mentioned that this is actually a part of this area, okay, you know in your mind what I mean. So this is a different picture, but you know it. Though it's a 2D image, you know that this is not, discrete. It does not end here. So it has a continuum on the other side. Okay. Now, all this processing. So if I told you that on the other side of this, on the right side of the brain, you get, say, X and Y. Okay. You can imagine where exactly is the position. So this actually occipital lobe, parietal lobe, and the frontal lobe. So all these three work together to give you that idea. Now, so when I say the occipital lobe, the frontal lobe, it's not this whole area per se. There are specific points, okay, on these areas that actually are able to do specific functions. But they work in liaison, in coordination with other parts of the brain. Now, why am I talking so much of brain and neuroscience when we are doing a course on science of happiness? The reason is that after this, when we talk of emotions, and as you know, happiness is an emotion, you will see that there are specific markers of happiness which you can measure. Okay, so to measure that, how will you do it? Or say, if you want to see the effect of, the effect of doing maths on your mood. Okay, so how are you going to do that experiment unless you know how will you see the effect? One is you can see it subjectively. How do you feel? You ask the individual, the person says, yes, I feel great, okay, after doing maths. So somebody who doesn't like doing maths will say that, okay, I feel horrible after doing maths. Okay. Now, on the other hand, the objective measures would include you putting some instruments in place to check out certain parameters. Okay. And these parameters, as I mentioned in the previous slide, would be across the body, not only in the brain. But in the brain also, there are some specific areas that are related to this. Another reason why I'm mentioning this is that there are some areas of the brain that, as I said, specific for important functions or important emotions in this case. So if there is a lesion, if there is an injury or damage in a particular part of the brain, then that actually brings about a loss of that function. Now, all of you are aware of this, that if somebody has a stroke, okay, so now what happens, he may lose a function like talking, or say movement of facial muscles, or movement of one side of the body, and so on. Sometimes, there are some areas in the brain which, if those are damaged, then this sense of there's a bluntness of emotion. So I don't feel happy, I don't feel sad, I don't feel anything. There are some disorders, okay, of the brain that disturbs these areas as well. So some neurological disorders that actually cause, or psychiatric disorders that cause bluntness of emotions. So there's a kind of illness called schizophrenia, where people sometimes have a bluntness of affect, so, or a flattened affect. So they would be talking like, yes, it was very sad when my father died, and I had an accident and I lost my job. So it's a very blank way of saying it. There's no feeling that's attached to the statements. So this happens. So when we are talking of emotions, we are talking of happiness, we need to understand that there are disorders or distortions of the same. Now, again, on the other hand, there are some illnesses when you will see people are exuberant. Okay, so there's something called bipolar disorder, where people have two poles, switches between two poles of moods. Okay, so one is a euphoric, excited mood, and the other is sad and depressed mood. So a person may be going through a switch, like for say 2 months or 3 months, the person is sitting in his room, not going out, and has grown a beard and unkempt and not taking a bath, and not eating properly, not talking to people. Then suddenly there's a gradual switch, okay, and the person then switches to the other pole. What's the other pole? A euphoric manic state. So walking around throughout the night, restless, working for 20 hours a day, not sleeping at all, okay, and talking a lot, spending a lot of money, using a lot of perfume, and doing all kinds of erratic things. But there's a lot of, so there's an exuberance, and if you ask that person, he's full of energy, he's very happy. Now the question is that, is that happiness? Is that happiness? It's very different. It's very different from what we term as happiness, what we term as a positive emotion, in the normal. So we will discuss this a little later. Now, there are certain areas in the brain, specifically this area called the nucleus accumbens in the prefrontal cortex. So as I mentioned right now, the frontal lobe, the frontal area of the frontal lobe again is known as prefrontal cortex. Okay. and there are it also has separate divisions. Okay, so but in whole, the prefrontal cortex, in the prefrontal cortex, there is a small nucleus known as nucleus accumbens, which is related to happiness. And there are wonderful studies by some Japanese researchers who show how nucleus accumbens is also related to hopefulness, optimism, and gratefulness. So there is high activity in these areas when a person feels hopeful, feels positive, feels grateful. So if you show gratitude, okay, if you are feeling good about the world, then this area gets activated. Now, can anybody tell me that when I say this area is activated, okay, high activity in this area, how do we know about it? Do you, anybody have an idea?
Fast neurons, electrical activity is going
Yes, but how do we know?
neuro-
Anybody else?
through signal processing.
Yes, through signal processing. But what signals? Sort of let somebody else also say if they are not sleeping. Rahul Sharma, are you sleeping?
No, ma'am.
Okay, any idea? Anybody else? Orko Prabhu,
Maybe by doing scans.
by doing scans. Okay, scans are
With
tell
better
you. So
like that.
if it's a CT scan or if it's an MRI scan, we will talk about it. Okay, they actually tell you structural positions. Okay, but how do we know that there is activity in this place when somebody is feeling gratitude, somebody is feeling optimistic? How do we know? There must be some kind of tapping that area, right? So, anybody, any idea? There are 24. How many people are there in this class?
Ma'am,
34. Yes, Sabhas?
we use EEG or something where we detect.
EEG, yes, very good. EEG, but EEG actually tells us about the electrical stimulation in a specific, in a larger area. Should I say that it will tell you that there is electrical activity in and around the nucleus accumbens, but it cannot tell us specifically that this is the particular nucleus that is active.
Okay.
Okay, but it's good. Yes, EEG is one of the mechanisms. Yes, anybody else? Okay, have you heard of fMRI? Anybody?
Yes, ma'am.
Okay, Debayani, what does fMRI do?
Ma'am, it's like not sure how does it work. I've heard about it, read about it. I've forgotten about how does it work
Okay,
exactly.
okay, just a wild guess. What does it do? Anybody else also? Okay, you all heard about MRI, magnetic resonance
Yes.
imaging, right?
Yes.
Okay, so MRI, what it does is it clicks pictures, okay, of your brain, and actually not of your brain per se, but it can give you images of any part of the body, okay, and multiple images, and it actually gives you structural images. So we will discuss this in detail. But because I'm mentioning things, that include fMRI, MRI, CT scan, so that's EEG. That's why I'm just highlighting on it a little. Okay. fMRI, on the other hand, gives us it actually identifies which part of the brain is at work right now. So it works on a concept known as bold technique. So It measures the oxygenated blood flow in an area of the brain. What's the hypothesis? It works on the principle that when you are working, when your brain is active, in any task, during a task, a specific area of the brain, and logically, if a specific area of the brain is engaged more in that task, it will require more oxygenated blood. Okay, so working on this concept, we will discuss this in details. I will show you how a machine looks like. Actually, the MRI machine and the fMRI machine is the same. Okay, so has anybody gone through an MRI over here? No? Okay. So there's a gantry kind of thing. So you put on a bed, and that bed goes inside. So it's a covered dome-shaped structure inside, and there are multiple sounds like kah, 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 kah. This kind of sound goes on continuously, and your body is strapped, and you are moved a little, and that's how the images are taken. But it's a little in fMRI, you can actually do a task, and that's what we look at. So if you are asked to, if you're doing mathematics, okay, you're doing algebra, and then at that point in time, your brain is being functionally, your brain's functions are being recorded through fMRI. It will show an activation, or this we call this area is activated or lights up. Okay, that implies that certain areas of the brain are requiring more oxygenated blood, and that's the kind of images that fMRI records. I'll show you some images right now. So that's why when I say that, well, there is high activity in nucleus accumbens, we see that this area lights up when a person is feeling hopeful, when a person is feeling optimistic and grateful, and also when the person is feeling happy. Okay, so that's why we say that, well, this area of the brain is definitely has something to do with happiness, and it also implies that these parameters of feeling good about things, feeling optimistic, feeling satisfied with the world, feeling grateful towards the world, are related to happiness. Subsequent research has shown that in depressed people, there is very low activity in this area, and also they feel extremely helpless, they feel hapless, or they do not have any hope about the world. So depressed people, in depression, we see that there is hopelessness, there is helplessness, and worthlessness about the world, self, and future. So you see, if these exist, so that implies that the person does not feel grateful. So hopelessness is there instead of hopefulness. Optimism, there is no sense of feeling good about the future, or self feels that, well, there's nothing good to happen, and feels worthless. Okay, so these are classical features of depression. So again, this just implies that if these areas are related to high activity in or rather these behaviors or these thought processes are related to high activity in nucleus accumbens. On the other hand, when there is low activity, these or in depression, there is low activity in this area, and these happen in depression. These are correlated with depression. So that just implies once again that these three factors are very, very important in happiness. So you will find in other classes also, you will find that teachers speak about, gratefulness. If you gratitude being an important parameter in feeling happy. So, in fact, in my slide also, I will talk about how you can feel better if you are feeling grateful towards the world. But you need to understand that there are specific areas in the brain that get lighted up if you're feeling grateful. And when that area lights up, when that area is active, stimulated, then you need to, you will feel good about yourself as well. So it's not like you feel grateful towards somebody else, that is just discrete. You feel grateful about that person and you feel bad about yourself. It's not like that. It also spreads to feeling good about yourself. So, this is how is this actually done? People will often tell you that, you do a gratitude task, you help people, you interact with people, so that actually, just give me a minute, please. So if you feel good about people, if you feel gratitude about people, then that will help you to function well. Actually, the thing is that it's the same areas in the brain that get activated. So it spreads to other tasks as well. That is what we direct towards in therapy. Yes.
Does that area get affected even if we are like sleeping or dreaming about, like if we are dreaming something that we are happy about, so will that area get stimulated with it?
No,
So we
see, it's a wonderful question. It's a wonderful question, Rohit. The problem is that when you are dreaming, it's actually the unless the sensations are there. Sometimes we feel that I'm having these sensations, but the sensations may not really happen to your body. It's not. It's just an image, and the moment you get up from that dream, you realize that it was a dream. Just give me a minute, please. Somebody seems to be calling me. Just give me a minute. Okay, sorry about that. So yes, Rohit. So if that's a wonderful question. So if you're dreaming, what happens in dreams? In dreams, we are seeing the image. We may also go through. We may think, or in the dream, we feel that we are going through these emotions. But other than you're feeling happy in the dream, do you feel the same sensations in the body? Other than feeling a shiver or stuck up problem with breathing. Now that's so the triggers of the dream may be a bodily sensation. For example, if you're feeling very cold and you don't have a blanket with you, you may see the dream may be that you are shivering in the South Pole. Okay, but that's how the imagery gets related. But the imagery of a happy feeling or happy emotion does not get transferred to the what should I say, the core expression or core feeling state. We do feel sad, say in the dream. Say suppose I see that I am going through a bereavement, okay, and I feel very sad, and I get up from the dream, okay. The feeling continues for a period in time, but the difference is that I know it's a dream. The moment I get up, I know it's a dream, so it will not continue beyond a time. The feeling good, especially, it we do not continue that after the dream is done. The dream, and there's something uh, different about imagery, or say in hallucinations. Okay, in a dream, when you get up, you know that, okay, this was, even if it's a very, very scary dream, the moment you are awake, you know that it's over. It was a dream. In hallucinations, you may be going through some, imagery, but you don't know that it's not real. To you, it's very, very real. So somebody having visual hallucinations, think about John Nash. If you have seen Beautiful Mind, you will know what I'm talking about. Okay, so the person feels the emotions, but when he gets up, he may think that it's not true. But in hallucinations, like in visual hallucinations, John Nash saw a child, okay, who would talk to him, and to him that was very real. So a person may think that, well, I can see there's this friend I have who talks to me, or there is God who is in front of me and talking to me, and I can see God in standing in front of me talking to me, or I can see the devil standing in front of me and talking to me. And he feels that this is very real. This is not, and it just does not snap off, like, and you get back to reality. That doesn't happen. Okay, so definitely there are some tricks that the brain plays in making that person believe that this is real. So similarly, a person who is manic, feeling extremely euphoric. Okay, I have seen, I'll just cite an example from here, from the institute. One student, he was having a manic episode. He was in Patel Hall, if you guys know Patel Hall. Okay, and this was years back, maybe a decade back. Okay, so he was, he told me, as a psychologist, I had gone to visit him. So because he wasn't leaving his room, but he lived in the third floor, and he said that, well, top floor, and he said that, well, look at this coin, ma'am. If I have the power. He hadn't slept for 3 days. He was walking around restlessly in his room, trying to solve some mathematical problems. And then he said that, see, I have the power to bend this coin. If I stare at this coin, I can bend it. Okay. And he's very, very, very excited and happy and energetic. And he said, see, if I jump from here, nothing will happen to me. I am absolutely powerful, full powerful. So, and he spoke to me very, very excitedly. And so it's the difference is this guy has some problems with the neurochemicals in the brain. This is nothing to do with feeling happy or feeling good about self. He is, of course, feeling good about about himself, but it is the link between reality and this excessive emotion. So that reality context is lost. For example, just you may feel extremely excited in the dream, but when you feel like jumping and shouting and crying and whatever, but when you wake up, you will not do all those things because they are not appropriate to the situational demand. For a manic patient, he will jump and shout and yell and cry and whatever, show his exuberance without realizing that it is inappropriate to the situation. Okay, so it's a little dicey, but anyways. Now, so what is the work of happiness studies primarily? What they do is they try to change, to link the, the thought and the emotion together, and they try and use intentionality to change the emotion. I was just speaking about this a little while ago when I said that, in what we do in depression is, because we know that these areas, these features are important for happiness or for positive emotion. In depression, we try to reduce this to increase this. So what do? You know that we need to increase this activity. So to increase this activity, what do you need to do? You need to do these. Okay. Then by default, these will lessen. Okay. Now, how do you do that? So so there are, in fact, now just to go by some more evidence, it has been found. Richard Davidson is a person who he's a neuroscientist who works on emotions, and his research is really wonderful. You can look through it. So he says he's found that the left side of the prefrontal cortex is more active when people are happy. So this area, and there are the right side of the prefrontal cortex, or the right prefrontal cortex, right side of the frontal lobe, is more active when people are sad. So now we know specific areas. Okay, so what we need to do, we need to make the person train to feel happier. So we need to train the person to feel happier, and we need to calm the activity in the right prefrontal cortex. Okay, so reduce activity in the right areas. Now, can this be done? Does it sound very far-fetched? Tell me. Do you think this is possible? This is impossible? And here I'm not talking of medicine, stimulating an area by medicine, stimulating an area by electricity, electrical charges, nothing like that. You're doing it by behavior. Is that possible? Doing it by thought.
I think certain practices over time, repeated behaviors may have some impact.
Okay.
Ma'am, I had another question. Can I ask now?
Yes, sure.
Ma'am, in cases, at times, it has been observed that people have mixed emotions. At
Yes.
certain points, at certain incidents, people experience both happiness and sadness, or like two dichotomous situations together, and that is quite intense. That becomes quite intensive when it comes to bipolar mm, effect. So what happens actually, the way you were explaining, maybe because I am not from biology or psychology background, can you please elaborate something on that, the mixed feelings thing?
Okay, so we'll start with the first one first. That when we are so it is possible to train the brain to do certain things. Now, of late, there's a specific area of neuroscience called social affective neuroscience, or affective neuroscience specifically, that looks into this. And there are forms of therapy, psychotherapy, which actually address these areas of the brain. But you do not, but you cannot find direct linkages. Like, if I have chocolate today, I will increase serotonin in my brain, and that's why I will feel happy about it. It can be very, very time limited. Okay. So long time, as you mentioned right now, that long-term continuous actions actually help to change certain neural patterns in the brain, and or I should say neural circuits in the brain. And you form different associations, you form different patterns of thinking, and because of that, these the previous neural connections, the energy in that gets lost. I'll explain this a little more. What happens is that if you are practicing new ways, for example, say if I say that every morning when I get up, I look at my result. In my last exam, I have done drastically. Okay, and every morning I had got my result at morning. Okay, so every morning when I get up, I look at my mobile, I check my result, and I feel bad about it, and my whole day is bad. Okay, so how can I feel sad, and I feel depressed. I don't do anything good. I don't feel like working. I get irritated with people around me and all that. Okay, so how can I change it? So if I stop looking at it, if I start my day instead of looking at the mobile, but with some other action. So it could be that every morning I get up and solve a puzzle, okay, or I do some exercise, or something that's unrelated to this behavior. Then with time, the thought process that's linked with the result and result to what have I done in life, and nothing is good. So all these connected pathways, they get this link becomes weaker. And I, even if I say at the start, if I start exercise, I might still have the inclination to think. Even if I haven't seen the mobile, I might have thoughts about, array, I've done such a horrible result, and my life is not good, or I lost a job, I didn't get a job, and whatever. Every morning, if that's a thought that keeps coming to me, even if I do not trigger that thought actively, it might come to me initially. But if I change the patterns of my behavior, it will also change the patterns in my thinking. So it will not get me back to that same link, neural network of one thought following the other. So it definitely requires practice, and this is what we teach in a kind of therapy called cognitive behavior therapy. Now, so there are some now coming to your next question, there are some mixed. Most of the times we do not show a true emotion. Okay, or when I say a true emotion or a pure emotion, what it means is that we actually have more than one emotion together. But generally, it's two positive emotions together. So it could be surprise and happiness, or say anger and sadness. Okay, two negative emotions together. It's rarely, but we do have ambivalent affective states, like say bittersweetness or nostalgia. Okay, so you feel good about it and also feel bad about it. So when such things happen, it's actually both the areas getting activated. Both the areas getting activated, but definitely say there is always a bent on the heavier balance. So for example, if you feel bittersweet about something, or say if you feel nostalgic about visiting your birthplace, okay, definitely you feel good about going there, you also feel sad about going there, right? Now, what's the more dominant emotion here?
It can be the good one of going there.
Yes. So so when we talk about an ambivalent effect, so both are present, but the other emotion, the weaker emotion, will be less active. Okay, so we go more with the dominant emotion, right? So it does not, in neuroscientific terms, it means that both the areas are activated, but the intensity of the activation is definitely depends on the vacillation effect, which is getting more impact, which is having more impact. There's a wonderful article by Damasio on this. Okay, let me see if I can find the article and download. If I can get it, I will. I think I might just be able to. I'll otherwise I'll post the. I'll download the article and share it. Okay, in the files section, you can look through it. Okay, so anyways, just give me. Damasio had, if you look at Damasio's work, Antonio Damasio. Has anybody read Antonio Damasio? Nobody? Anybody heard of Antonio Damasio? He's written a wonderful book called Descartes' Error. Okay, if you get an opportunity, please read that book. Okay, it's a beautiful book. Okay, so it talks. I spoke about the mind-body dualism. Remember that whether they are connected to each other, whether the brain, whether they are linked or they are not linked. So Damasio, Descartes said that there was the pineal gland linked the mind and the body together. So there's Damasio actually says that Descartes was errored. So he's named that book by the same title. So read the book if you get a chance. It's not hardcore neuroscience. It's popular writing, and it's very interesting. And in fact, Damasio has worked on decision making, and he says that how emotions affect our decision making. If we do not have emotions, we will not be able to take a decision. So the emotions actually help to sway the favor towards a particular decision. There's a wonderful video on this also. You can check it out on YouTube. So now I was saying that, well, it's not too far-fetched. Actually, you can train the brain to feel good. Okay, so CBT, a therapeutic form called cognitive behavior therapy, is actually practicing this. What do? In CBT, we believe that cognition, behavior, and emotion are interlinked. Okay, and you can influence one to affect the other or influence the other. So if you train one, it will influence the others. For example, say if you're feeling good about yourself, if your thought is, okay, I can do it, then you will try something. So there will be a positive behavior. And if the thought is I can do it, definitely the emotion is also positive. But say if you think that I am no good, okay, मुझसे तो नहीं होगा. Okay, if the thought is मुझसे नहीं होगा, then or the world is hopeless. यार फालतू है, कुछ क्या फायदा? If that's the thought, क्या फायदा? Then you will not try anything. Okay, and your emotion will also be on the negative side. Okay, if you're not sad, you will at least be angry or slightly low in the mood spectrum. So so what we do is we train individuals to think positive, and also we train so you can approach mood or you can approach emotions through two ways, because they are all the three are thought, mood, and behavior are linked. So we address either from the thought or from the behavior. So we say that, okay, you're not feeling good about yourself. Okay, you don't need to think about how good you are feeling. Okay, you just need to do this action. Get up at morning and go for a walk. It doesn't matter how you're feeling. Like, you don't need to think whether you feel good or you feel bad or so and so. You just do the action. And once you continue to do the action, there are certain changes in the brain. Okay, and these are definitely neurobiological changes, neurochemical changes rather. So, and it brings about a change in the way you look at the world. You feel good. Okay, so your action brings about a change in the emotion, and when you have a change in the emotion, then kya fayda ya mujhse nahi hoga ya the world is bad, that will also change because the thought and the mood and the behavior are linked. Okay, so I'll probably share a flow chart of how we do it in depression and anxiety. So when we are talking about happiness now, specifically happiness, it isn't simply a pleasurable feeling, but it's much more complex. So happiness, again, as I mentioned earlier, that happiness is not a very it's an umbrella term, and there are you can term pleasure as happiness. So a short term pleasure of having chocolate. हाँ, मैं बहुत खुश हूँ. India wins an ODI, मैं बहुत खुश हूँ. World Cup, India wins World Cup, मैं excited हूँ. Okay, बहुत खुश हूँ. So now, it can be explained in multiple terms. I got a job, my dream job, बहुत खुश हूँ. Okay, so now it can differ from individual to individual. It can differ within the same individual or in different times. So today, if when I was small, if somebody gave me a new book, okay, to read, I would feel very happy, exuberant. Mera to, maybe a week would go great. Okay, if somebody allowed me to watch a movie, that would be amazing, because we did not have so many channels and we didn't have so many options for books and whatever. But today, all that is easily available and accessible to me. So does that give me the same amount of happiness? No. So it changes over time. It changes over age. It changes over perspectives. Okay. So when we say that it changes, it also changes because of certain hormones. Okay. And hormones are that can be because of some bodily features also. So some changes in the body. For example, say adolescents feel more sad and irritated than any other age groups. Okay, does not mean they don't feel happy and excited, but now they go through a lot of turmoil. Okay, we call it's the age of stress and storm. Okay, in the teen years. Okay, now why is that so? There is also, so it's definitely a transition from childhood to adulthood, but and there are a lot of changes in the social system, in the social roles that the person was playing. Earlier he was considered a child, now he's considered an adult. But along with that, there are change in the bodily features. So a boy of 14, 15 years has now grown. There's a change in his voice. There's a beard that's coming out. He's suddenly grown tall and feels awkward. He's not considered as I said, the roles are changed. He's not considered as a child anymore, but neither is he considered an adult. Okay, so all these are definitely, as I said, some of the social roles are important, but beyond that, there are, because of these secondary sexual changes, there are because of hormones, these changes occur, and these hormones have also a very important role to play in mood. So when I am saying that when we are talking of happiness, or when we are talking of moods or positive emotions, we must also understand that there are multiple influences on the positive emotion. So it's not only, I feel good, I feel bad. Okay, that subjective feature is not enough. If a person who is ill might say, when I say ill, and It's not necessary that a person will feel bad, will feel sad because the person is ill. Like in manic disorder, the person may feel exuberant and excited, but that is not happiness. That is related to some changes in his brain or in his neurochemicals. Now, similarly, if a person is undergoing some changes in his hormones, that may make him feel unhappy about everything in the world. And no matter how much you tell that person to feel gratitude towards the rest of the world, it will not make him feel happy because there's some change in the biology. Okay, so unless that's fixed, he will not be able to feel happy. Okay, so that's why I said that, when we're talking of this happiness per se, there are many factors that are important and that are correlated. Now, now, if we talk about, if we say that all things considered normal, how do you rewire your brain for happiness? Can you actually do that? We spoke about cognitive behavior therapy, and you can actually connect your, so when we say rewire your brain, so you can tweak some neural connections in your brain, okay, to make you feel happier. Now, what does that mean? You cannot change the, can you change the thought line from A to B to B to Z to P1? Can you change that? Yes, you can. So the connections, one thought follows the other for all of us. So for any random thought, Okay. Now you need to change the rewiring. So if you've had, say, an unpleasant interview, and if you've had a very bitter interview and things went bad, okay. Now I'll give you another live example. Say if COVID, the word COVID is related to, say, some negative events in your life, and every time that you think of COVID, okay, it brings in these negative thoughts. So there's a link, there's a network that's of thoughts, of words that are linked to the word COVID. Okay, unpleasant memories, maybe unpleasant situations or whatever. Now, can you change the way you think about it? It's not going to change the situation. Please understand, when we do this rewiring, it does not mean that forget everything that's happened, forget whatever unpleasant has happened. It's not that. But you train your brain to engage in actions so that the next time you think about something, so if it's COVID also, it gives you something different, some different way to approach the word COVID. Now it can be, that's why it's very idiosyncratic. Idiosyncratic means very unique to the person you are addressing. If how I perceive COVID will definitely be different from the way you perceive COVID. So engaging in actions that may lead to new pathways will be very different between, of what you should try and what I should try. And that is why an active participation of the individual is required. It's not like having medicines. I give you a medicine, you don't have to do anything, you just eat that medicine, you'll be fine. It's not like that. Okay, so if you wish to change the way you think, if you wish to feel good about yourself or about the world, you need to actively participate to do it. And how do you do that? So you can engage in practices and activities that can raise the happiness quotient. So I was just mentioning in one of the slides before that gratitude, optimism, these are related to the area in the brain that is again related to happiness. So if you can practice such acts, it will definitely activate this area. So these are some of the activities that you can do to increase your happiness spectrum or happiness set point. So meditation, the reason is that it reduces the activity in the right prefrontal cortex. It calms the brain. So if it calms the brain, the sense of agitation that we feel with distress, the muscle tightness that we feel with distress, that is reduced. Just to give you an example, say, think about your class 10 or earlier. If whole day you waited for your results and at the end of the day it didn't come out, okay, you did nothing but you just sat and you waited, oh my god, abhi niklega, and whatever, tak nikla nahi, yeah, ऐसे कोई interview के results या जो भी हो. Now at the end of the day you'll see that you're feeling very tired. You didn't move around, run around, kuch nahi kiya. Then why are you feeling so tired? It's because your muscles were taut. Okay, so T-A-U-T, taut means tight. Okay, so when we are anxious, our muscles become tightened, so they contract. Okay, and the reason is that we are ready. When we are anxious, our body is ready to fight or flight. Okay, so it's like an emergency. To save ourselves, we need to either run away from that place or fight. So that's how the body responds. And if you are doing that for a long period in time, you're anxious for a long period in time, your body will get tired. So does the brain. Now, anxious people, they always, you can look at yourself right now and see if your fist is folded as you sit. Are your muscles tensed as you are talking, as you're listening right now? So many times, even when we are sitting and listening to something, our fists are closed and we are, our muscles are tight, or there's a pull in one of the muscle groups. I mean, I'm just contracting it without my knowledge. So anxious people generally, they have this tautness of muscles for a longer period in time, and that anxiety, that's the bodily featured expression of anxiety. So what you can do is, this is definitely not related to positive emotions. So meditation helps to calm the brain. It also helps to reduce these muscle contractions. It helps you to relax. And the more relaxed you are, the better you will be able to, feel about yourself or feel about your mental state. So, relaxation, again, relaxation has a high correlation with well-being. And this is again, researched and well found out. Interactions, social interactions help us to feel good. Okay. One of the primary reasons is that because we are social animals, we through evolution have learned to survive in groups. We are not Robinson Crusoe. And in fact, even Robinson Crusoe would not be able to survive without Friday, right? So we prefer, or rather we are primed in our DNA to survive as a group, to take help from people, to interact with people and survive. So, interact with nature as well, interact with people, interact with nature. If we do not do that, then we will by default feel low. Our mood will go down. So that's why, you will see that, in happiness studies, we say that if you want to practice happiness, how do you do it? You interact more with people. So you interact more with nature. This is our, our genetic propensity to feel good. We interact with the environment around us. Just to give you another example of this is that, when there is sensory deprivation. Do you know what sensory deprivation is? Anybody? What is sensory deprivation? No idea? Nobody knows what is sensory deprivation? Okay. Uh, Sensory deprivation means that when you are devoid of a stimulus. Okay. So say you are kept in the dark, okay, or in artificial light for say 6 months, or you are kept without sound for 4 months. Okay. They would practice this in prisons earlier. Okay. So you are not allowed any light, any sound. So Kalkutri was such kind of a thing that they practiced in prisons. Okay, so the other is, so sensory deprivation affects the mood. Okay, and because we are, as I said, because we are primed, humans are primed to interact with people, interact with nature. So if there is a deprivation of the natural stimulus, we feel depressed, we feel ill. And that's why a lot of studies have been done with people who have stayed in artificial environments for months together. Can you give me an example of an artificial environment for months? Okay. How many students are sleeping? Please put up your hands. Excellent. Excellent. Okay. So who has not put up his hand? Okay. Aviral Jain. Are you there in class? Aviral?
Yes, ma'am.
Okay. What was my question? To which
I'm
everybody put
sorry.
up their hand?
I'm sorry I missed it, ma'am.
Okay. Okay. Anybody else? Rahul Sharma. Are you there? Okay. Boishali.
Ma'am.
Yes. What was my question? To which everybody put up their hands?
Yes, who is sleeping in now?
Okay. Yes, exactly. So how many students are sleeping in right now? Okay, and we have, let's see how many hands. Amazing, amazing. So all the people who put up their hands are actually sleeping, right? You all agree?
No, ma'am.
Yeah,
No, ma'am.
but you were the first one
No,
to put
ma'am.
up your hand, Abhas.
Yes, ma'am. I thought
And the moment you put up your hand, the others immediately followed you without even realizing what they are putting up their hands for. But definitely Miss has asked something, ma'am has asked something, so let's all put up our hands. Right? I didn't ask.
We thought that
Yes?
I mean we didn't
No,
connect those two
we
things.
thought
thought that
like
people who are sleeping can't raise their hands, so we need to raise our
yes,
hands.
Okay.
that's why we put up our
Okay.
hand. We thought like we are not sleeping, so we have to put up our hand.
Okay. So I definitely am very specific with the words I use. So please follow it next time. So if the next time I see that all these hands go up when I say how many people are sleeping, then you will be marked absent. Okay, despite attending a drilling class of 1.5 hours or 2 hours. Okay, so Ananya Verma, please put your hand down. Please lower your hand. Okay, so can you give me an example of sensory deprivation for months together? Or can you give me an example of an artificial environment where natural stimuli are absent for months together, days together?
Like suppose someone has got a fracture in his leg, he does not uses his legs for a month or two sometimes, and when the plaster gets cut off, then it feels something totally different.
Exactly, exactly. Very good, very good. Any other? So the sensory, okay, so the sensations were not present there. Okay, that's more because of the blood circulation. Uh, Anything else where you can move around, but you are in an artificial environment? A classic example of an artificial environment. Where the natural stimulus, say light, sound, air, all
Yes,
this
ma'am,
is
when the astronaut go to space.
perfect, perfect. So there's a wonderful book by Scott Kelly. Okay, do you know, does anybody know about Scott Kelly over here? No? Okay, Mark Kelly and Scott Kelly, they are two astronauts, okay, and they are twins. And one of them was sent to space. He lived in the space station for 18 months, and the other brother was here. Okay, and when he came back after 18 months, we saw that he definitely looks younger than his brother. Okay, so Scott Kelly has a book on his time in space and endurance. Okay, so you can go through that book. And what he, why I brought this up is that, you know, in an artificial environment, if because we are primed to be with nature, because we are primed to social interaction, if we are kept in an artificial environment, it disturbs our mental balance. So to feel good, to be happy, to not feel the negative emotions, you need to have fun, you need to have social interaction. Just to give you an example, people who have been isolated and staying at home for these last 2 years, most of the people feel negative. So there is a high rise of anxiety and depression over these 2 years, especially among the young adults. Why? See, because that's the time when they socialize more, interact more with their fellow beings. And that has been entirely stopped, no matter how much the Facebook and other social media sites are active. Okay. So to increase your well-being, this is very important. This gets affected when a person is not feeling good. So that's the first thing one avoids, social interactions. Physical exercise is another very important factor for improving well-being and positive emotions. As I mentioned, exercise not only makes you feel, you know, active or feel good about your body, so the aches and pains they reduce, but also due to the blood circulation in the body, okay, you feel more, what should I say, that you feel more active to get up and do tasks, instead of you know, the brain does not get the signal that, oh no, not again, I have to get up. If you don't exercise, then getting up and going to switch on the light is also a huge effort. But if you exercise daily, then your body does not give this information to the brain that this is a tiring task. That's number one. Number two is exercise, uh, you know, gives way to or releases some neurotransmitters, okay, like endorphins, that reduces pain. So it also reduces both physical pain as well as psychological pain. And serotonin, again, that's a hormone that's related to emotions. So now, that's why if you exercise daily, if you do, especially if you do some cardiovascular exercise, what then you feel your well-being improves. What is cardiovascular exercise? Cardiovascular exercise is where your heart rate increases and you than your normal, and you sweat because of the effort that you put in. Okay, so cycling, swimming, running, walking, brisk walking, okay, not the garden walk, brisk walking, jogging, spot jumping, all these are cardiovascular exercise. The other kind of exercise that I've not mentioned here is cognitive exercise, that also helps to boost the spirits. Why? because it activates the brain. That is, if you do some puzzles, Sudoku, word play, everybody is doing Wordle right now. So if you do these, that will also activate your brain. It will help you feel better. Okay, so see, physical exercise helps your body feel better, and that information goes to the brain that, okay, I feel good about myself, I feel good about my body, and that makes you, it also changes the mood. Cognitive exercise helps you feel good about your brain, that, array, my brain functions. So you feel, these subtle feedbacks to the brain go from different parts of the body, and all these increase your well-being. So you need to rewire your brain to these tasks. The other one is gratitude, saying thank you. This is one task that has been seen to be very, very good in improving well-being and happiness. So this is, you can try this. So the first part of it, in today's discussion, I actually spoke about the biological aspects, and I connected happiness and positive moods to different areas of the brain and how we can rewire those areas. And here I'm telling you some of the self-help techniques to increase your well-being. So this is one task that you can do yourself. So set yourself a task of giving thanks to 5 people this week for something either they have done or some characteristic they possess for which you are grateful, and learn to say thank you. So this is, this increases a sense of subjective well-being. So far we were talking about objective parameters. Here we are talking about subjective well-being. This is another way to increase well-being. Delayed gratification, because with the speeding lifestyle, we generally do not delay for something. Okay, and you will see that if you get something immediately when you want it, you feel good, but that feeling good or that ecstasy is short lasting. And this has been seen through, neuroscience, that if you delay the gratification, if you hold it for longer, the pleasure is more. I'm not talking about happiness over here. I'm talking just about pleasure, but that pleasure is more. Now, delayed gratification means, say, if you want an ice cream right now, can you wait for not having it now and having it a little later? Or if you want a book right now, instead of that, why, if you can wait for a little later, rather than just at that point in time going and buying the book or ordering it on Amazon. That task itself is also an action towards gratification. Even if you get the book after 3 days from Amazon, it's not delayed gratification. You have immediately taken up that task. Okay. Now, if you hold it, if you feel like, say, if you're very angry with somebody, you feel like abusing that person, wait, pause for a while. Do not do it immediately. And it has been seen that, if you delay the gratification, then it helps to feel better. Okay, but there's also another thing that develops with delayed gratification, that is a sense of self-control. So if you develop a sense of self-control, you feel good about yourself. It's a very subtle way of feeling good about yourself, that, well, I can deal with things. Okay, I can deal with my impulses. So this is a very good habit that you can develop. Okay, it will not only help you with, feeling positive or feeling happy. I'm not saying it will directly make you feel happy, but it will help you get a grasp over yourself. So it's not that I'm suggesting that you do not have a grasp over yourself, but what I'm suggesting is it increases discipline, it increases self-control, and it's very easy to practice. For example, if you decide that this week I am not going to have non-veg, okay, now when you decided that you are not going to have non-veg, that day you didn't know, your friend comes and invites you to have dinner at his place in the next 2 days. Okay, so you say, अच्छा चलो छोड़ देते, अगले हफ्ते करेंगे. That you've dropped your self-control. If you cannot control your impulses, if you do not delay this gratification, then you will not be able to work in a disciplined way in other things also. So practicing any habit, practicing or developing a habit or practicing tasks, it has its effects or impact on other areas of life as well. Okay, and it has been shown that there are two areas in the brain, the PFC and the ventral striatum, that are related with gratification. And it has been seen that in addictions, these areas, people who find it difficult to delay gratification show high activity in the ventral striatum that is related to addiction. So people who have addictions cannot stop themselves, cannot stop their impulses. Now, you can actually try this to discipline yourself. You decide anything for yourself. Say, I will walk a kilometer every day. Okay, no matter what happens. So, even if it's raining, you take an umbrella and walk a kilometer. So it's a task that you have set yourself. Okay, I will, so that's for self-control. For delayed gratification, I will not have this at this immediately. So learning to keep things for later, it helps to improve the overall well-being instead of impulse gratification. So you can try that. So basically, this is, so today's session, I will not, it's 9:30 now, I will not start something new. Today's class, we initially spoke about the specific brain areas that are involved, that are engaged in emotions. And from there, we went to how thoughts and feelings and emotions are, or rather thoughts, feelings and behavior are connected, and how we can rewire our brain. Okay, what is the research that we have in this area, and how we can rewire our brain to feel good. So this is as of today. In the next class, we'll start with something called neurophysiology of emotions. It's a little, you might feel it a little dicey, but what I will try and do is I'll try and make it as simple as possible, and we will do some exercise in the class that will